Hi, folks. I want to talk to you a little bit about the way that we start with one line and we start thinking about things like parallel lines and perpendicular lines. We now have a bunch of information that can help us to do this. And I think the biggest piece of information that I want to start with is that we just looked at cases where we have a system of equations where we say, hey, these are going to have no solutions. And the main thing that we noticed that told us that a system was going to have no solutions was that it had the same slope. So here's what we're going to get into today. We will be successful if you're able to do this. I give you a graph or I give you an equation of a line, and you're able to tell me the slope of a line that's parallel to that line that I gave you. Or I give you a graph of a line or an equation of a line, and you're able to give me the slope of a line that's perpendicular to that line that I showed. So we're going to start with this graph that we're looking at here. And, one of the first things that I want to notice about this graph is that we can find its slope. So the slope of this graph would be that we could start here. Let's identify, first of all, that this is the y-intercept point at 1. And then we can see that this is decreasing, going down by 1 and going over by 3. And so our slope here, our slope is negative 1/3. Our y-intercept, since we're already here, our y-intercept is positive 1. So that's our b is positive 1. And if we really wanted to, we could go ahead and start writing this equation. We know that this is going to be y equals mx plus b. This m here, this is m, our slope. This is our slope. Oh, this is our slope, negative 1/3. That's our slope number. And then this is our y-intercept number. And so we would write that the equation for this line is y equals negative 1/3 x plus 1. So, because of the work that we did with systems of equations where we found that they had no solutions, when I look at this line and I say, hey, okay, you've given me a graph and I can tell you the slope of a line that's parallel to this, we already identified that the slope of this line has a slope of negative 1/3. So we know that any line that's going to be parallel to this is going to have that same slope number. So a line that is parallel to this line that is drawn, well, this has a slope of negative 1/3, so the slope of the parallel line would be negative 1/3. And that really grows out of the work that we did with the systems of equations when we found that sometimes they had one solution, sometimes no solution, sometimes infinite number of solutions. We're going to dive right into the next possibility here. What if I want a perpendicular line to this? Now we're going to have to do a little more thinking here. So what I'm going to draw is I'm going to draw that same slope triangle that we drew. So this went down and then it went over, went down by 1 and over by 3. And now I'm going to start to imagine, and I'm going to kind of sketch it out for you a little bit. I'm going to start to imagine, what if I wanted to take this line and turn it 90 degrees? Because really, that's what perpendicular means. It means that we're going to rotate this 90 degrees. The line that we want is 90 degrees to that. That's perpendicular. It means it's at a 90-degree angle to this. So what I'm going to do to help us sort of picture this is I'm going to kind of fill in a rectangle. I don't know why. It's just easier for me to think about this problem if I make kind of a rectangle. Now, this is not a math thing. This is just to help you to picture what I'm talking about. I'm actually going to even color it in. This is absolutely not a mathy thing. This is a way to help you to picture this. So what I want to do is I want to take this, and I'm going to take this line and I'm going to rotate it 90 degrees. Well, if I rotate that line by 90 degrees, Well, the slope triangle rotates with it. It's attached to these 2 points. It's attached to this point and this point, this 0, 1, and 3, 0. So if I rotate this whole figure, I'm going to draw what that slope triangle looks like. I'm actually going to think of this whole rectangle. And so this rectangle, the way that I have it as a slope triangle for my original line, is sort of short and fat. And so when I rotate that, imagine if you had a box and it was short and fat and then you tipped it on its end. Well, that would be tall and skinny. So that's what's going to happen here. This slope triangle, I'm going to just draw it in a different color here, is going to go from being 3 units wide and 1 unit tall. It's going to tip up on its side, and it's going to be tall and skinny. So 3 by 1 this way. Okay. So that slope triangle, let's sort of sketch it in here. Okay. That slope triangle, instead of being, actually I don't want that inside there. Let's clean that up here because I'm gonna want to know where that line is. Okay. So when I rotated that up, this purple, right? This purple rotated. This purple rotated to like right there. Okay. And then that red line cut across there. That red line cut across there. I'm going to use a blue. That red line cut across there. And you can kind of see what we've got going on here. The original line, when it tips up with that slope triangle, starts looking like this. Okay, and we know that line keeps going on forever. Okay, I did a terrible job drawing straight. But the idea here is, if I want to imagine a line that is perpendicular to this red line that has a slope of -1/3, we would rotate it 90 degrees, and then I want you to notice the slope of this new perpendicular line. Take a moment and notice the slope of that perpendicular line. Instead of going down a negative slope, in fact, let's note that this original had a slope of -1/3, right? That original was going down. It had a slope of 1/3. Instead, now, this blue line has a positive slope. That blue line is increasing. That's going to have a positive slope. I'm just going to put a little positive sign. We don't usually write it, but put that right there. Now, when I think of the slope of that blue line, well, I have a slope triangle drawn here. And I've even really counted how far it went up and how far it went over. My rise here is 3. And my run for that new perpendicular line is 1. So instead of having a slope of -1/3, the line that is perpendicular to that original line has a slope of 3/1, or we could say it has a slope of 3. So a line that would be perpendicular to this original line would have an opposite sign. So it went from negative to positive, and we flipped the fraction. Instead of 1/3, it's 3/1. So we call that the reciprocal. Opposite reciprocal. I hope I spelled that right. So we change the sign from positive to negative or negative to positive. So that's the opposite part. I'm just going to put a little plus, minus, positive, negative, opposite. And then reciprocal is where we flip the fraction. So perpendicular line has the opposite reciprocal slope. Okay? So, what happens if I give you an equation? Well, it's the same thing. It's the same information that we already know. We know that if I want a line that is parallel to a line that has this equation, well, I just have to first of all recognize that this 2/3 is the slope and this 1 is the y-intercept. So for a line that is parallel to this line, well, I just want to make sure that I have a line that has a slope of 2/3. Now, if I don't want it to be the same line, infinite solutions, if I don't want it to be a line that is concurrent, a line that's exactly on top of it, but I want it to be up a little or down a little, I would just have to change my y-intercept. And I could change this to pretty much anything. So I could say y equals 2/3 x plus 5. And this would be a line that is parallel to my original line. So keep the same slope. Keep the same slope. And I guess I would say, since we don't really want a line that's the same line, I would say change the y-intercept. You can pretty much choose whatever you want. Okay? So finally, what if I give you the equation of a line and I say, okay, well now I want the perpendicular to that line. Okay, well we learned in the previous example that I'm going to take this slope. I'm going to take this slope of my original 2/3. And if I want the perpendicular, then I want to do the opposite. So this was positive. I'm going to do opposite sign, negative, opposite, and then reciprocal. I'm going to flip this fraction, 3/2. I guess technically I could say that's 1.5 or 1.5. So the slope of a line that is perpendicular to this line, y equals 2/3 x plus 1, would have a slope of -3/2. And I could actually make an equation that had a different y-intercept or the same y-intercept. It doesn't matter, because they just said, hey, give me a line that is perpendicular. What's the slope of a line that is perpendicular? That's all I have to tell you today.